Hello, everyone. Hello, everyone. Welcome back to our live tutorial classes. In this tutorial class, we are going to begin differential equation focus. We are going to tackle the meaning of differential equations as well as the classification. We have the types of differential equations, the order, the degree. We have the homogeneity, the linearity, and the other parameters which we are going to consider in this live tutorial. Please stay glued to your seat as I'm going to take you through the fundamentals of differential equations. So to begin with this tutorial class, I'm going to start with the types of differential equation. So let's see, what is differential equation? We've done several types of equations from high school, and we know we have linear equations, quadratic equations, we have exponential equation, logarithmic equations, but we are going to tackle differential equations. Differential equations. So assuming you are doing, let's say, quadratic equation, you realize that what makes an equation quadratic is when you have x squared plus, let's say, a function 2x plus 1 is equal to 0. This becomes a quadratic equation because we have a quadratic term x squared here. You can have an exponential equation where you have an exponent, let's say 2 to the power x plus 4 equals 0, as well as logarithmic equation, which we have log of an expression 2x plus 1 all equals 5. So you realize that for the different types of equations, being quadratic or logarithm or exponential depends on the nature of the parameters within the equation. For that reason, differential equation, as the name suggests, differential. This is a type of equation which contains derivatives. Derivatives. So this is a build up on calculus 1, that is where you do the integration and differentiation of functions. So at this point, we are dealing with equations which has derivatives. You know, derivatives are represented as dy over dx, that is changing a function y over changing a function x. So if you have an equation which has derivatives or which contains, so any equation that contains derivative is called differential equation. So one may ask, why do we learn differential equation, or what's the goal for differential equation? Now, if you have, let's say, the y on the x is equal to 2x, you realize that this is a differential equation. This because the parameter here is a differential or is a derivative. For that reason, this equation, the y over the x, becomes a differential equation. The goal of every differential equation is to make our dependent variable the subject. So in this case, we are going to make y the subject. So if I have the y on the x is equal to anything, let's say 3x, my goal of solving this differential equation is to make my y the subject. So the case is, how do I make y the subject? So that is the whole goal of differential equation. And you know that we have different types of derivatives. Some functions are complex whilst others are simple. For that reason, differential equations have also been categorized into different groups. So we are going to delve more into the different classification of differential equation. So now starting from the types of differential equation, the types of differential equation. So we have the first type, which is ordinary differential equation. Ordinary differential equations. Now, when we say ordinary differential equations, these are types of differential equations which involves a function of only one. So see, the condition here is only one independent variable. Independent variable. So you can say that differential equations is a type of equation which involves the derivative of a function of only one variable. So I can have a function of t, I can have a function of what y, I can have a function of what x. Commonly, we use a function of x in most representations of our function. So meaning that for every ordinary differential equations, you are expecting the independent variable to be what? 1. So let's talk more about the ordinary differential equations. So when you say ordinary differential equations, these are types of equation which contains one at least. It contains at least one derivative of an unknown function. Unknown function. For example, I have dy on the x plus 2x is equal to 0. What this implies is that dy on the x, this is a function of x equal to y. So if you differentiate y, you are going to get dy with respect to what? The x. This makes this an ordinary differential equation, meaning that we had a function of only one variable, that is f of x, and we want to differentiate our function with respect to x. So seeing a derivative in our equation makes it differential equation. But looking at the number of independent variables, you can tell me that it is an ordinary differential equation because the number of independent variables we see in this equation is what? 1, that is x. So for every ordinary differential equation, you should expect only one independent variable as I listed it here. So there should be only one independent variable. That is, there should be a derivative of a function of a single variable. Now let's see another example of an ordinary differential equation. So you can have the squared y over the x squared is equal to sine of x. So seeing this equation, you realize that we have a higher derivative here, meaning that our equation here is a differential equation. But to know if it is an ordinary differential equation, you only have to consider the independent variable. How many are they? It's only one, that is x. So this is the same as a function of x, which is equal to y, and it was differentiated to give the y over the dx. So meaning it's a derivative of a function of a single variable. So meaning this equation here is an ordinary differential equation. Let's move to the second type of differential equations, which we call the partial differential equations. So when we talk about partial differential equations, all that we mean is we have a function of multiple variable. So we can have a function of x, y, z. So a situation where we have a derivative of a multivariable function. So the word is multivariable. So our function depends on x, depends on y, and depends on what z as well. So meaning whenever you want to differentiate such a function, you are going to differentiate our df of x. Sorry, we are going to, so let's make this the subject. Let's say this whole function to be y. So we are going to have an expression, let's say dy on dx plus dy on dy. I have y here, so I only assume, so I can make this a capital Y. It's just an illustration. Plus the a over dy plus the a over the z. This is what we call the partial derivatives of a multivariable function. So all that I'm drawing you towards is partial differential equations deals with equations which has partial derivatives of a multivariable function. So every equation with partial derivative of a multivariable function. So in this case, the condition here is there should be more than one independent variable. We can clearly see it from our illustration that our dependent variable y, or which is the function, depends on three independent variables x, y, and z. For that reason, if you have any differential equation containing the derivative of a multivariable function, then we will say that that equation is a partial differential equation. So let's see. If I have the u over the x plus the u over the y is equal to 0. So let's see from this this equation. We have the u over the x plus the u over the y is equal to 0. We can see that we have more than one independent variable, and that is x and y. So meaning our function u is equal to f of xy, and the partial derivative of u is u with respect to x as well as u with respect to what, y. So meaning that this equation that we have here is a partial differential equation. A partial differential equation. So whenever you want to identify whether an equation is ordinary or it is partial, the only thing to check is the number of independent variables. So that is your denominator, what you are differentiating your function with respect to. If we have only one independent variable, it means that our function will be differentiated with respect to only a single variable. In this case, where we have partial, our function will be differentiated with respect to all the independent variable within that multivariable function. We can have another example of partial differential equation to be d squared u over the t squared is equal to a squared d squared u over the x squared. So you can see that we have a higher derivative of what, a function u with respect to what, t is equal to a squared multiplying the higher derivative of the same function u with respect to what, x squared. So we can see that we have two independent variables here, and that is what, t and what, x. Meaning that our function u is equal to f of t of x. That is, it's a multivariable function. Therefore, the derivative of this function depends on these two independent variables, making this equation here a partial differential equation. Once we've known the types of differential equations, now let's move to the second part of our agenda, we have what we call the order of differential equation. So we call it order of differential equation. Now, from the types of differential equation I listed above, I said we have ODE, then we have PDE, where the ODE stands for ordinary differential equations and PDE stands for partial differential equation. In your differential equation course, our focus will be on ordinary differential equation, but not partial differential equation. So talking about order of differential equations, our focus will be order of ODE. Order of ODE. So when you say order of a differential equation, what does it mean? What does it mean to be or to say the order of differential equation? So when we say the order of differential equation, it simply means the highest derivative a differential equation contains. So the definition for order of ODE or order of differential equation is simply the highest, that's the key word here, derivative of a differential equation. So when you have a differential equation containing derivatives of a function, then the highest derivative within that particular differential equation becomes the order of differential equation. So now let's see from differential from differentiation, you know that we have the first derivative f prime, we have the second derivative f prime prime, third derivative f prime prime, then fourth in that order to what we call the higher derivatives. For this reason, if you are having any differential equation where the highest derivative is f prime, that is the first derivative, then we say that it has an order of what? 1. If the highest derivative in your differential equation is 2, that is f prime prime, then we say it has an order 2. Likewise, order 3, then this is order 4 in that manner. So the order of differential equation is simply the highest derivative a differential equation contains. So we can see that if I have a differential equation such as the cube x over the x cube plus 3x multiplying the y on the x is equal to e to the power y, then what is the order of this differential equation? You realize that from the definition we are saying that the order is the highest derivative of the differential equation. In my differential equation here, I have the cube, the x, the cube of x over the x